please. Let's try one more time. So let's refresh our memory on this formula. This is very important. How do I differentiate the natural log of a function?
Do we do 1 over this function?
1 over the function.
Okay. So,
Please don't resist what I said. Times.
d over dx?
Correct. But in this case, we write f prime times the inner function prime. So let's go back to what we have then.
So it's 1 over 2x cubed minus 2x plus 1 times 6x. Yeah.
Minus 2.
That's it. Perfect. Now let's work on this one. So we have a function x cubed times e to 2x squared minus 1. Then we want to find f prime. Yes, I'm ready.
3x squared.
Very good. Awesome. Because it's the product rule. Plus x cubed times how do we differentiate e to a function prime?
4x.
What is the formula for e to a function prime?
We're trying to find g prime.
Yes, but I have to differentiate this and put it here. First function prime times the second function plus the first function times the second function prime. So e to a function. How do we differentiate e to a function?
Is it e to the function prime? E to the f times the inner function prime?
Exactly. Awesome. Can anyone tell us what to write in here?
To e to the power of 2x squared minus 1.
I have to write this.
E to the 2x squared minus 1 times 4x.
That's it. E to the function times the inner function prime, which is 4x. Yes, we normally have to continue and simplify it, but I said you can leave it as is. Okay, so let's look at the related rates. And that's on page 364. So, where are you guys? Okay. Okay, 364. What is going on? What did I do? I want 364. I don't want the cover. Okay. So, any related rates? Given y equals such and such, find this. So let's choose a related rates to refresh our memory on related rates. And then we have one more to look at, a graph. Can anyone choose, or I will?
Number 17.
717, very good. So we have p squared times q and they're asking us, which is y equals, and they're asking us to find dq over dt when p equals 15, q equals 40, dp over dt equals 55, and dy over dt equals 54750. Perfect. Where are you guys? Here. Okay. So, this tells me that I have to put a dot on the Q. This tells me that I have to put a dot on the P. And this tells me that I have to put a dot on the Y. Meaning all these are functions of T. I will differentiate implicitly. So, tell me what to write. What do I write? I have to write dy over dt. This is the product rule. 2p dp over dt times q plus p squared times q prime, which is dq over dt. They want us to find dq over dt. This is our variable. This has to go to the other side. It changes its sign, and I have to divide by p squared. So dq over dt will be dy over dt minus, because this term goes to the other side, it doesn't have the variable, it goes to the other side, as minus 2pq dp over dt. It's done. I just want to plug in the numbers. So p, this has to be replaced by 15. Q, this has to be replaced by 40. dp over dt, this has to be replaced by 55. P squared, this has to be replaced by 15 squared. Don't try to simplify. This is not a factor here, please. And dy over dt is 54750. So now dq over dt equals 54750 minus 2 times 15, 30 times 40 times 55, everything divided by 15 squared, which is 225. I put this in the graphing calculator to get the final answer. Careful how you do it. That's not what I meant. I meant this. Parentheses at the top, 54750. Minus 30 times 40, 1200, and then times 55, and divide by 225. So negative 50. So that's a related rate situation. Why? These three functions are related by that equation. Their derivatives are related by this equation. That's why they are related rates. They are related by this equation. And any questions on this problem? Final problem that I'd like to at least start. We have many examples, is graphing. So let's choose, if we don't finish it, I know I'm running out of time, I have 5 minutes left. Okay. So let's say x minus 3 over x plus 4. So they're asking us to fill out the entire table, which means the derivative, which means the function, and the second derivative. This is what is given credit for. So we are asked to graph this function. Can anyone identify the domain of this function?
Negative infinity, negative 4, infinity.
Very good. You don't have to write it on the side. it's sufficient for me if you do this. I know what you're saying. Good. What do you know about x equals -4? What will that be for sure? Very good. Immediately you know that left and right, you have to find infinities. What you don't know is the sign. But you know that once you put this in, you have to have infinities left and right. Maybe both positive, maybe both negative, positive, negative, negative, positive. I don't know. But I will find the limit right now. The limit as x approaches -4 from the left of x minus 3 over x plus 4, and the limit as x approaches -4 from the right of x minus 3 over x plus 4. You know it has to be infinities. They have to be. But we don't know the sign. So -4 from the left is with -4, with -4.1. -4.1 plus 4, this is negative. But also here, -4.1 minus 3 is also negative. So then what is the sign?
Positive.
That's it. Here with -4 from the right is -3.9, but -3.9, this will cover it, so it will be positive, but the numerator still stays negative. What is the sign?
Negative.
That's it. I also have to plug in 0. When I plug in 0, I get -3/4. I also have to set equal to 0. When I set f of x equal to 0, how much is x? When is a fraction 0? A fraction is 0 only when?
The numerator is 0.
Exactly. And when is the numerator 0 for this function?
When x is +3.
That's it. Awesome. I only need these limits. And I'm done with the function. We have to exhaust the function first before we go to the first and the second derivatives. So, how do I find these limits? Very easy. So let's find limit as x approaches infinity from x minus 3 over x plus 4. Remember, this is infinity over infinity, so I have to factor out the degree. So x approaches infinity, x and x. And yes, eventually these will go away. So this is 1 minus 3 over x, and this is 1 plus 4 over x. So now, where is 3 over x going when x approaches infinity? Remember, tiny over huge. Tiny over huge. Exactly 0, very good. So this will approach 0, this will approach 0. So then, what is this limit? Limit x approaches infinity, this is 1, this is 1, what is the limit? That's it. That is the horizontal asymptote. 1, y equals 1, horizontal asymptote, 1. So, I know I'm running out of time, so what I would like you to do for next time, and we'll finish it in a few minutes on Monday, please find the first derivative, find critical numbers if they exist, and put the sign here. Please find the second derivative, see if there are any inflection points, and then we will graph the function together. And that completes our review.